Hi. This tutorial is the grand finale of our Advent calendar, and we're wrapping things up by using a Kaggle dataset packed with over 700 fantastic Christmas movies. We're going to explore how to build a recommendation system. Whether you're a movie buff looking for new holiday favorites or a coding enthusiast eager to try something fun, this tutorial is here to help you out. We'll walk through the steps together, learning how to transform your data, store it, and create a simple interface. By the end, you'll have the skills to make your own awesome holiday movie search engine and save some time to everyone looking for that perfect movie night. Let's get started. To kick things off, our initial step involves data loading and cleaning. We will do all the preparation steps in a Jupyter notebook that we will link in the description. Before we start, you will need to download the dataset from Kaggle's and save the CSV in the same folder as the notebook with this name christmasmovies.csv. We'll start by importing the pandas library to work with our dataset. Upon loading the data, our primary focus is to filter out all entries except movies. This helps narrow down our dataset to specifically work with Christmas films. Upon closer inspection of the movie descriptions, we notice the need for some data cleaning. We'll engage in refining these descriptions by addressing inconsistencies and ensuring uniformity throughout the dataset. Furthermore, we exclude films with missing values. Selecting only the most relevant columns, we create a consolidated feature set. The title, description, genre, director, and stars will serve as the foundational elements for comparing films and crafting recommendations. So we combine them into one column. Finally, we add another ID column. This is how the prepared data looks like. Now, let's dive into the exciting part. We've laid the groundwork by selecting specific features like title or description for movie comparisons. But how does this comparison process unfold? Computers operate in a world of numbers, and to enable them to understand and process textual data, we need to convert words into numerical representations. However, it's not just about converting words into numbers randomly. We aim to transform them in a manner that ensures related words or concepts are closer together in a mathematical space. And this is what embeddings are. In our case, to get embeddings for each film, we can leverage the OpenAI API. This API provides a powerful mechanism to generate embeddings for text data. We'll begin by importing the necessary libraries and setting up the OpenAI API by inputting our unique API key. Using the client.embeddings.create function, we can then create embeddings for our movie dataset. To achieve this, we'll employ a Lambda function, which allows us to seamlessly apply the embedding generation procedure to each entry within our dataset. This means that for every movie in our dataset, we'll extract embeddings using the OpenAI API, effectively transforming the textual information into numerical representations. This can take some minutes. Our embeddings, while rich in information, have a high number of dimensions, 1536 to be precise. Such high dimensions space is difficult to understand. Hence, we'll compress these multi-dimensional vectors down to a more manageable 2D space and visualize it. To achieve this, we'll employ the TSNE algorithm. This is a powerful technique commonly used to reduce high-dimensional data into lower dimensions while preserving the inherent structure and relationships between data points as much as possible. In this visualization, similar movies have similar embeddings and tend to cluster together. Now, we can better understand how our recommendation system perceives the relationships between different Christmas films based on their textual features. We'll now set up our vector database. There are several options that you can choose. In our case, we decided to go with Pinecone, one of the most well-known. Before we proceed, it's important to create an account that grants access to the free trial version, providing us with the necessary API key and environment settings. Once we've obtained our credentials, we'll begin by importing the Pinecone library. The initial step involves creating our first index within the database. Here, we'll define the index's name, dimensionality, and the metric used for similarity calculation. We'll use cosine similarity in this case, a common metric for measuring similarity between vectors. With our index created, the next step is to initialize it, setting the stage for data insertion. We'll proceed to populate the index in batches using the upsert method, effectively adding our movie embeddings and IDs to the database. This process establishes a foundational structure within our vector database, enabling efficient storage and retrieval of movie embeddings. This database will serve as the backbone of our recommendation system, facilitating quick and accurate searches based on similarities between movies. And that is it, we have a perfectly functional search engine. Let's try it out. We write a prompt that is our search, wants to ruin Christmas. We must get its embeddings as before using the OpenAI API, and we can query our index, passing the prompt embeddings and the number of results. Voila! These are the top 10 closest films. We see movies like How to Ruin Christmas, which the title is very close to the prompt, or The Grinch, with a very similar description. To have a rounded project, we will do a simple user interface using Microsoft Power Apps. For that we have to prepare a couple of things. First, within our dataset, we have access to links pointing to the covers of these festive films. We'll leverage this information by saving these cover images to a folder in SharePoint. With this piece of code we can download the images to the specified folder. We have created it within the shared documents of SharePoint to have access from Power Apps. Additionally, we'll prepare a CSV file containing relevant details, such as movie titles and description. This CSV file will serve as the foundation to create a SharePoint list, a crucial component that will power our app's functionality. With these foundational elements in place, our app will be equipped not only with comprehensive movie data but also with engaging visual representations, enriching the user experience and enhancing the overall appeal of our Christmas movie recommendation platform. Let's put all the pieces together. To store our Christmas movies, we will use a SharePoint list. A SharePoint list comes in handy to interact with our Power App later. To create a SharePoint list, you can start from scratch, or import an existing list from a CSV file. After selecting the corresponding data types for each column, we can create the new list with our Christmas movies. The next step will be to create a Power Automate flow which is triggered by the Power App. The idea is that the flow sends the keywords the user entered to the Azure OpenAI API and converts the keywords to embeddings. The embedding is then sent to the Pinecone database where a search is performed to find the nearest matching movies. The Pinecone API returns the IDs from the top 10 closest movies. This flow usually takes 1 to 2 seconds. Finally, we can create our Power Apps. In the app, we need a field where the user can enter a keyword search. This search can contain movie titles, movie descriptions, genres, and actors. Then we need a button that triggers the flow, passing the search text. The flow will search for the best matching movies and returns a list. Finally, we display the results in a collection and the user can read details about the movie. Congratulations! You have made your own film recommendation system. Let's review all the steps and see how we can interact with our vector database and how we use OpenAI embeddings. We had a dataset with more than 700 different movies, each one with its own description. We can interact with OpenAI API by using Python. And we did use Pinecone as vector database. Now we can send all descriptions to the OpenAI model. The model creates embedding and returns them. We gather all of the vectors in our Pinecone database. So, how do we use the vectors in our database? Imagine Paul, who is looking for a nice movie for the evening. He types in his search terms. We take his search as input and send it to OpenAI. We get an embedding for Paul's search, just like we did before with the movie descriptions. We feed that vector in our database. The database uses our input and will collect the topmost fitting matches from our movie vectors. It will return the ID and the vectors. Finally, we can easily identify the corresponding movie titles. As output, we get a nice list of recommended movies for the evening. Paul can choose the top movie from our list. Have a nice movie night.